Continuous charge distribution. Okay, so distribution of the charges continuously. Say for example, I'll consider a conductor like this. Say conductor AB. Now, if you give the charges to this conductor, if I give a charge Q to the conductor, then all those charges are equally distributed along the length of the conductor continuously. That means these charges do not accumulate at this point, but they are continuously distributed along the length of the conductor. Therefore, that is called as the continuous distribution of the charges. Right? Say if you give the charges, say electrons to this conductor, then all those electrons are continuously distributed along the length. Now we have three types of the charge distribution. First one, linear charge distribution. Second one, surface charge distribution. Third one, it is volume charge distribution. Now if I go with the first one, that is linear charge distribution. That means if you give a charge to the conductor, then continuously they are distributed. If along the direction of the length, then it is called as the linear charge distribution. Say for example, I have a conductor, say AB, right, that has the length L. Now if I give Q amount of the charges to this conductor, then these all charges are distributed along the length of the conductor. Okay, so such distribution is called as the linear charge distribution. Here we are going to define an important point, that is linear charge density. Okay, so linear charge density. Okay, so with respect to linear charge distribution, we are going to define linear charge distribution, which is denoted by lambda. Okay, so lambda is always equal to Q divided by, say if it is the charges are capital, then take some as Q, right, divided by L. Okay, so that means linear charge distribution in linear charge density in linear charge distribution, it is the ratio of charge given to the conductor to the length of the conductor. Lambda is equal to Q divided by L. Therefore, I can write the SI unit also here. Right? What is the SI unit? Q coulomb, right? Length per meter. Therefore, coulomb per meter is the SI unit of the linear charge density. Similarly, if I go with the second one, that is the surface charge density. Say for example, right, if I consider a sphere like this sphere, then if you give the charge Q to this sphere, metallic sphere, then all the charges are continuously, right, distributed over the surface of the sphere here. Therefore, such a distribution is called as the surface charge distribution. With respect to surface charge distribution, we can define surface charge density. Okay, it's the number of the charges per surface area, like that. Okay, so it is denoted by sigma. Sigma is equal to total charge given to the surface area of the surface of the conductor. Okay, sigma is equal to Q by L. Therefore, if you want to write the SI unit for coulomb, it is for charge it is coulomb, for area it is meter. Coulomb per meter square. It is the SI unit there. Then next one, that is volume charge distribution. So for example, if I have, right, a conductor like this, then if a charge of Q is given to the conductor, then it distributed over all the surface of the conductor, hence all the charges are distributed over the volume of the surface there. Okay, such a distribution is called as the volume charge distribution. With respect to volume charge distribution, we can define volume charge density, which is denoted by rho, is equal to, right, how much charge is given, Q divided by volume of the surface. Of course, the unit is coulomb per meter cube. Okay, so that is the SI unit of the volume charge density. Okay, so therefore, with respect to three charge distribution, we have three types of the charge density.